Welcome, everybody. I'm Lucian Fogoros. I'm the co-founder of IoT World, and I'd like to welcome you to this session of the program focused on industrial metaverse on the road to decarbonization. We have an exciting panel. So without further ado, I'd like to introduce Mike Lake, who will moderate this panel. Mike, the floor is yours.
Thank you, Lucian, and welcome to everybody. My name is Mike Lake. I'm the president and CEO of Leading Cities. We're a global nonprofit organization that drives resiliency and sustainability for all by really unlocking the potential of the world's cities. So we're operating right here in the center of the smart cities space. I want to quickly thank our friends at IIoT World for creating World Smart Cities and Buildings Day and bringing us all together. This is truly an amazing opportunity for us to share our insights, to learn from one another, and to make new connections. I'm also really excited and honored to be moderating this panel. And I want to welcome our speakers. This morning we're joined by Lee Chambers and John Burton. Lee is the Chief Commercial Officer for the Active Building Center. He leads a team of pioneers focused on the commercial application of innovative technology in the buildings industry. Lee has a long history in senior sales roles with the last 15 years spent in solar energy. As we'll see shortly, Lee really takes pleasure in questioning the established wisdom on the basis that if you always do what you've always done, you always get what you've got. Which is, I think, just a great philosophy to have to continue questioning that. We're also joined by John Burton. John is a serial entrepreneur with extensive expertise in technology and manufacturing. He is the co-founder and CEO of Ursa.Leo, an immersive 3D platform that combines digital twin technology with real-time and historical data. In less than 3 years, John and his co-founder have raised funding and built a platform that is disrupting the way IoT data is visualized, collected, and analyzed, while also transforming industries that include energy, construction, to talk about, and manufacturing. Gentlemen, as I said, I'm honored to be moderating this panel with both of you today. This issue that we're going to be talking about and focusing on in terms of decarbonization and building, it is a huge piece of the biggest issue I think we're all facing, which of course is climate change. So the fact that we need to be tackling this by decarbonizing, especially in our buildings, is really a paramount concern to anyone and everyone. As some have said, the younger generations of today are going to be the first generation to really feel the impact of climate change, and likely the last generation that will have the ability to really do something about it. So clearly, since industrialization, generation after generation has been kicking this can down the road. But the end of the road is finally in sight. Everywhere we turn, there are opportunities to do something about our carbon footprints. But one of the biggest emitters or offenders, however you want to look at it, of carbon may surprise the average person in the fact that it's our buildings. The UN has shared that buildings represent 39% of global greenhouse gas emissions. And so reducing, these emissions in buildings will be a critical factor to achieving net zero emissions by 2050. In fact, the UN also suggests that to get on track for net zero by that time, emissions from buildings will have to be cut in half by the end of this decade. And indirect emissions from power generation for electricity and commercial heating and the like actually have to come down by 60%. Further compounding this already existing challenge of our buildings, the World Economic Forum reports that the global building floor space is projected to double by 2060. And only 3% of the investment in new construction is green and efficient. That locks in high emissions for decades and decades to come. Of course, we also have to deal with our existing building stock. The World Economic Forum talks about this in terms of the renovation rate of existing buildings is barely 1%, which is less than a third of the rate needed to actually meet the Paris climate goals. So look, we have the greatest existential threat to humanity staring us in the face. the buildings we live in, work in, and indirectly rely on daily are a major contributor to carbon emissions. So now that I've kicked this discussion off on a rather somber note, John and Lee, I'm counting on you to help us see the opportunities that exist for the world to take immediate action, to turn this ship around. So before I depress anyone any further, let's really jump into this. And certainly my brief introductions of both of you just don't do justice to the impressive work and background you each have. So can you take a moment to briefly introduce yourselves a bit further? And also, while you're at it, share with our audience a bit about how Active Building Center is working with Ursa Leo. So Lee, let's start with you.
Yeah, sure. Good afternoon from the UK, everybody. So I'm Lee Chambers. I'm Chief Commercial Officer for the Active Building Centre. The Active Building Centre is a government-funded research technology organisation currently, with a remit to look at intelligent energy systems in buildings. But we do so much more than that. We are currently involved in lots and lots of projects where net zero is the goal, levelling up of our society is the key. And generally speaking, we are trying as best we can in these difficult times to reduce the fuel poverty. So we're all about the social good and the socioeconomic impact of zero carbon buildings. And if I speak a little bit about Ursa Leo and how we became involved with them, it was purely and simply because I was looking for an intelligent way to bring all of the things in buildings together in a dynamic simulation, and a way that people could understand and see things like energy flows and the ways parts of interactive buildings happened with each other. And it was so I could get something all in one place, because at the moment, wherever you look, it's always something different, and technology doesn't talk to each other, it doesn't work with each other. And if you're ever going to get to zero carbon anything, you've got to look at the building as a whole, you've got to take a holistic approach, and you've got to have some joined up IIoT thinking. Thank you.
Oh, thank you. And John, please introduce yourself a little bit further.
Yeah, so John Burton, I'm in San Francisco. I've known Lee now for a good year plus. We've been working together. My background actually is in the hardware business. So I was selling sensors into buildings, industrial applications, and just thought that the way that data was being gathered and looked at was pretty archaic. My co-founder is Angie Stitcher. She had done a 10-year stint at Apple. So when I sat down with her over a glass of wine and said, I want to start a company to tackle this, I want to take an Apple sort of approach. Apple's made consumer data so easy to utilize. You don't think about how to use a smartphone, you just use it. So that was kind of our initial remit. We've got to make all this data come together in a way that's understandable. And that's how we started the company, and that's evolved into focusing on buildings and energy and decarbonization. Just a quick comment on your slightly doomsy start there. One of the really interesting things that I've found, what you read in the press is governments aren't doing enough, and that's probably true. But governments, especially democratically elected governments, have voters to answer to, and voters tend not to vote for hard things. So governments are going to be constrained, and that's just a fact of life. What I'm seeing in working in this industry is a huge amount of private money moving into building decarbonisation and green initiatives. University of London issued a £300 million bond, which is for decarbonising their campus. Stanford University, $300 million bond. One of Lee's customers just raised $500 million in the private equity market. So I think private money is, a lot of investment funds want a good percentage of their funds in green projects, and to Lee's point, being able to show what those green projects are and how they're working is going to be absolutely key to keep those guys happy and keep their checkbooks open.
Absolutely. And we're going to dive into the discussion now. And I just want to remind all of our audience participants that if you do have questions throughout the discussion, please submit them via the question and answer feature here in Zoom. And at the end, we'll be opening the floor to those questions. So don't wait till the end to submit them as you have them. So First of all, thank you again, both of you, for not just being with us today, but for the incredible work and collaboration you're doing and the impact that it's having. But before we get too deep into this exciting discussion, perhaps you could take just a quick minute to provide a little more context to the discussion, particularly for those who may not already know about digital twins. Would you please describe what they are? John, maybe we'll start with you on that.
Yeah, unfortunately, it's become a little bit of a buzzword. So people apply it to all sorts of different things. At the very lowest level, it's just a set of numbers that represent real things. So the temperature number is the actual temperature, the humidity number is the actual humidity. I think what's much more interesting in the digital twin world is when you get into 3D representations of objects, and that can be a building, it can be a city, and that's the area we operate in. So I wish I could find a phrase that would nail down exactly what we do, but digital twin has become the industry standard way of talking about representing real objects in the computer world.
That's really helpful. Thank you. So now getting into the heart of the matter here. How can this digital twin technology actually be applied directly to buildings to generate the impact that is so desperately needed to achieve our decarbonization goals? Lee, I'm going to toss that one to you.
Okay, so look, the UK construction industry is, what was the word you used, John? Archaic. We like to think we're doing things cutting edge, but actually we're really not. And we do a lot of business as usual, which of course gets us where we'd always got, which I believe I borrowed from Henry Ford. It's a simple case of, we need to do something different, and we need to do it different now. We haven't time to waste anymore. And using a digital twin for us at the Active Building Centre is absolutely key to what we do. We'll take a 3D digital model of a building, and then we'll use location-specific dynamic simulation modeling to predict the things that will happen in that building through its lifetime or through an average year, so that we can see if there's going to be overheating, we can see if there's going to be a need for cooling, we can see what the energy demand potentially is. We can add in different types of technologies and factors and move them all around and optimize the building to be as zero carbon as it could possibly be right from the drawing board. And we can do that in both new build and retrofit. That's 1% of all of buildings.
Just listening to you say that, you reminded me of something a dear friend and mentor of mine 20 some odd years ago said to me, which is that the ability to visualize the future is a key success factor for anybody's success. And now, just listening to you, I'm realizing that that's true not just of personal success, it's true when we look at the success of buildings and our efforts to decarbonize. And correct me if I'm wrong, but that's essentially, and maybe John, this is what Ursuleo does. It visualizes tremendous amounts of data that would be it's impossible for the human mind to actually compute on its own.
Yeah, so I think if you look at the sort of what happens when we go into decarbonizing a building, let's take a new building just for the sake of argument. So the architect designs it, and there's great tools out there to simulate the heat usage of the building or the energy usage of the building. So that's typically done at the design phase. It's then presented to external investors who want to invest in green technology. And they go, fantastic, this building is going to be net zero, and we'll throw a bunch of money into it. The building is then built, and then the investors come back around a few months later and say, okay, we'd like some proof that this thing is really doing what you said it was going to do. And simulations are simulations, real buildings are real buildings, the two may differ. So having that final piece, which is being able to monitor all the energy usage in the building, which obviously is just putting in sensors, but also display it and sitting in a boardroom in front of high-powered investors and display it in such a way that makes sense to them. That's kind of where we come in, because putting up a bunch of numbers and just going, hey, look, this one's zero, that's not going to wow guys from Wall Street. So being able to show a model of the building with all the energy usage and see the energy flowing around it, and having a power meter in the top corner that fluctuates between but over time is hitting zero. We're seeing some strong interest in that.
So Can you dive a little deeper on, once you see it, what's the next step?
Yeah, so next step is controlling things. That is something that we are interested in implementing. We haven't done it yet. People get there's big security concerns around that one. So, the ultimate goal is absolutely, I've got a 3D model of a building on my iPad, and I can turn the temperature down, and I can turn pieces of equipment off if they're consuming too much power, or I can switch power around from solar cells to batteries and sell to the grid and buy from the grid. That's kind of the ultimate goal of where we're going with this. Anyone's listening, we're very interested in talking to any beta customers who'd be help us with the use cases around that. I think the biggest challenge there is the security angle. You've got to have rock solid security, and not people can't hack into the building.
No, great point. So, look, we all live in homes. Obviously, as urbanization continues, density increases, there are going to be larger and larger housing communities. So what do you see happening in the industry as it relates to energy management for large residential housing communities? Lee, what are your thoughts on that?
Well, I mean, we spend a lot of time at the ABC trying to decentralize energy. So starting with the units themselves and building things like microgrids so we can move energy around holistically inside the development before we start stepping back up, or trading energy. We do quite a bit of work at the moment on visualizing, recording and tokenizing flows of energy so that we can actually effectively sell from house to house, or we can change the way things are generated. For example, we could pass the energy through to a school on a site, or we could pass it from house A to house B, or we could collectively collaborate all of those assets and feed them back to the grid in times of demand and generate a revenue stream instead of a cost. There's so many things we can do and are doing. My only comment on it all is it's not going far enough, fast enough. And I use digital twins as a way of explaining how these things can all come together to benefit all of the people all of the time. So it's a very good way of seeing visually how complex parts work together.
I know this is a little bit of a departure from what we're talking about here, but you just brought up, selling from or sharing energy from house to house or to school or whatever. For those of us who live in a single family home, what is the opportunity for them? Again, I know this is a quick departure from our topic here, but clearly there are a lot of single family homes out there. So, is there something that the average person can actually start doing now so we can do more faster?
I think it depends on your situation. It depends on your location as well, because the rules around energy trading and energy storage and things like that vary from place to place. All I can comment really on is the UK and possibly Europe, where some of the regulations may stall that process because they're not as up to date as they should be. But there is an opportunity for everybody to generate some of their own energy, to use some of their own energy, to reduce the demand on the grid and therefore decarbonize by winding down power stations. So there's an opportunity there. I mean, it may not be possible for everybody immediately to link together and collectively pool their resources, but in different use cases and different scenarios, it's definitely possible. And in new build, it's much easier, but it is still possible in retrofit as well.
So let's drill down a little bit deeper on this side. Can you talk a little bit more, Lee, about the technology being used to spot, buy, and sell energy to the grid?
Okay, so I mean, obviously, you've got people with energy generation, say solar PV, for example, energy storage, battery systems, cars parked on their drive that may be bidirectionally charged. All these things are energy assets, and every energy asset can be assigned effectively an address in a digital twin. And the energy flows to and from that asset can be monitored constantly, and maybe in the future controlled, as John said. So every kilowatt hour of energy that's being used there can be tokenized. So it can be tagged, coded. And we can then take that effectively like you would stocks and shares and move it around. So it becomes an asset that's movable in its own right. And that potentially is possible with some platforms that we're working on at the moment. It's still very early stages, and the legislation doesn't really allow it at the moment, but I'm hopeful that, within a short time in the UK, at least there will be some pilot projects and legislation that allows us to have a digital platform that allows us to move energy around through transformers and as effectively as tokens.
And
crypto energy.
Sorry,
John, do you see in the future the 3D digital twin kind of concept, which has perfect application right now in larger scale buildings and uses, but is there a future for it in the single family home at some point?
Yeah, I think so. I think, one of the projects that I know Lee's involved with is a large residential builder who's putting in green homes in Oxfordshire, and then they're planning to expand and go to other places. And obviously people are buying these houses, A, because they're a nice house, but a big part of the reason is because these things are designed to be net zero and green. So somebody who wants to participate, they want their home to be not emit carbon, they are going to be looking for ways to get that information in a very visual form. So you just spent £1 million on a house, and they move in, and you say, okay, you tell me it's green, show me the information. I think being able to do that in a digital twin, again, it's just a nice way to show data off in a very visual format, and human beings, love it or hate it, are very visual, very visual things. So we just consume, and we could just consume information way better when it's presented to us graphically than we do as a series of numbers.
I know that's true of me. I'm definitely a visual person, so I appreciate what you're doing. It puts data in context in a much more digestible way, and it empowers us. And really, that's what we're talking about. Whether it's a building manager or an individual, what you're creating is a tool that empowers people to actually take the necessary steps or procedures or whatever to actually create the effect we're looking for. And it's critical to be empowered, because this is, as I started, this is a challenge that we're all facing. Like, we all have our role in contributing to it and contributing to the solution. So talking about the visualization piece, how do you see digital twins being used to visualize the huge digital quantity of information relating to energy usage, more specifically?
So the way we've actually done this is we've used gaming technology, and the reason we use Unity 3D gaming engine. The reason we do that is, if you think about a computer game, a 3D computer game, it's incredibly visual. And half our engineers are ex-gamer, developer, hacker sort of guys. So they've spent their entire careers trying to fully engage somebody to interact with a game. And the way you do that is through the graphics in the game and the visualizations of what's going on in the game. You don't want to play a game that's just an Excel spreadsheet. You want to play a game that is graphically going to draw you into the world. So take that same philosophy and actually the same tools and shift that over to the building side. There's almost an infinite number of things you can do. Zoom out to a university campus, you can see energy usage of each building on the campus. As you zoom down to a specific building, more information appears about the energy being used on each floor of the building. You zoom into a specific floor, energy appears about each room in the building. You can see energy flowing around the building. We do visualizations of literally arrows, that sort of green arrows show energy being generated, red arrows showing energy being consumed. We represent batteries as things that fill up and empty as they get charged and uncharged. So if you put all that together, sit up at 10,000 foot levels, see what's going on across a whole campus or a whole housing development, and then zoom down into a specific building or a specific floor or even a specific room to get to the super detail. And obviously you've also got alerts going off. So if something is going over preset thresholds, it'll show up on your 10,000 foot view, and you'll be able to zoom into that specific issue with a click of a mouse. So it's just taking that gaming philosophy about UI, has to be really cool philosophy, and applying it to this use case with tools that were available. So that's why we used them.
Lee, did you add anything to that?
No, I was just thinking, I was sort of, from what John said there, I mean, the ability to drill right the way down to an individual appliance using X amount of energy to come back out to a house, to come back out to a street, to come back out to an estate, to come back out to everything, right back to a power station and to a planet. That level of information and control is probably the key to our decarbonisation of the future. Because if we don't have that level of understanding about what's doing what, then we can't fix it. If it's not, if you can't see what's broken, you can't fix it. But
exactly right.
I was quick anecdote. I was talking to a university here in the US, and they're putting in our digital twins on a student housing. It's a 12-story building, which is lots of rooms on each floor where students live. And they actually see the students competing with each other. It's such, that generation are so obsessed with climate change and decarbonisation. They think if they can give all the students the information about energy usage through the building, everyone's going to be trying to be the person with the least energy footprint. So I thought that was just fun that, it's those sort of ideas coming along a little bit. Hopefully we don't have students freezing to death because it was in the Northeast. So.
I can kind of add to that as well a little bit, because we get involved in a lot of developments where we have energy communities. So what happens is that people are actively encouraged to conserve energy first and foremost. And then obviously if they use excess energy, then part of an energy community mechanism is for them to be penalised for excess use. So there's always a check and balance in the system that's fair. And it's, energy community is a democracy. They vote their own changes through, but they all stick to them. And therefore their energy demand is lowered because people are going around turning off lights. They're going around switching off the telly when it's not on. It makes a very big difference. Basic things like that can make a massive difference before you even start looking at anything else. But if you don't know what's on where and what isn't, or you can even control what's on where in a community and what isn't, then that makes a very massive difference, because that allows somebody to maybe intervene. For example, my children leave the lights on wherever they go. I go around turning them off. If one day John's digital twins can be enhanced to the point where I can sit on my iPhone and it tells me the kids have left the lights on and I can manually turn them off from my iPhone, then that would be a really good day for me.
All right, we'll get that done, Lee.
Yeah, exactly. Add it to the list.
Well, Lee, your story reminds me of an anecdote. This is actually about 15 years ago, but I met a gentleman who developed a device that you could plug into your home, and it would, simple, I mean, nothing as sophisticated as what John is doing, but it would tell you how much energy you were consuming. And he brought it home, tested it at his own home. And for the next 2 days, his children were running around the house, turning on any electrical device they could find. And he thought, oh, this is a disaster. This is exactly the opposite of what I'm looking for here. And then he said after the second day, it was his kids that were yelling at the parents every time they left something on. And what they did is, by turning everything on, they knew exactly how much energy every device was using when it was on. Mm-hmm. So it comes back to this point of empowerment. Lee, I think you might be pleasantly surprised that when your kids have access to it and are empowered by it, you might not even have to be the one that shuts off the lights anymore.
Well, possibly they may well, hopefully they'll be shutting off the lights themselves.
Exactly.
I think it's all about, like you said, it's about empowerment, it's about education, and it's about understanding. And quite correctly, as everybody's pointed out here, people are largely visual. And I don't mean to be horrible to Microsoft, but Excel depresses me. I would much rather see it in a digital twin. I would rather see it graphically represented where I can interact with it and where I can understand it easily without having to learn how it works. And I think that's critical to our low carbon future or zero carbon future.
Absolutely. I couldn't agree more. Well, we've talked a lot about the residential side, but I do want to ask, and John, this is probably a question for you. Can and how can this also be applied to large commercial buildings?
Yeah, I think that's a perfect use case, because large commercial buildings, everything tends to be connected on a single network already. So you've got access when sensors are installed. And by the way, retrofitting sensors is a pretty straightforward thing to do, especially power sensors. They just clamp around the wire, and then you have to connect them to an Ethernet network, and you're off to the races. So I think retrofitting commercial buildings, and definitely when you create a commercial building, sensors I think should become the de facto standard. EU's regulating around that. The UK's regulating around that. I think 20 US states so far have regulated around that. So I think that's coming. Just from that's where the governments really shine, is creating regulations saying you have to do this whether you like it or not. Once you have those sensors installed, you need a network, which every building these days is going to have a standard computer network installed. And then the sensors send data over that network to a industrial PC somewhere in the building. This is just a little $500, $600 box that sits there and literally collects the data, runs some software to encrypt it, and transmit it up to the cloud. Once it's in the cloud, you've then got a model of the building, and you can show all those sensors where they are, the power readings, the overall power each floor, the overall power of the entire building. So I think all of that technology exists. We're starting to see those projects come through. I think one of the issues that has sort of happened in the big commercial building industry is, there were some very expensive proprietary systems. There still are some very expensive proprietary systems. I've got a board member who's a senior architect at Google, and he's worked with those systems for years, and says, unfortunately, everyone got a little bit of a bad taste in their mouth. They got told this was all going to be amazing, and they can install these systems, and the building will be completely controllable. And the reality is that those systems tended to be over complex, hard to use, required training. They weren't intuitive, and back to everything we're talking about. If it's not intuitive and it's not easy, people stop doing it. But anyway, absolutely retrofit a building or installed sensors in a new building, collect that data. We just need an industrial PC, cheap box in the basement or somewhere to transmit the data. Then we can create the twin from the architectural drawings, and we can display all the information and the overall power usage. We work with an analytics company as well, so you can slice and dice the data over time. And then you've got a very good information set to start working on, making sure the building is doing what you think it's doing or should be doing.
Well, we've already had a number of questions submitted by our audience here. So just a reminder to everyone, if you do have a question, please submit it in the Q&A, the question and answer feature here on Zoom. Let's dive into some of these. I'm going to start with one from Sophia. A higher level question. What's the difference between digital twin and metaverse or virtual reality presence?
So good question. I mean, if anyone can tell me exactly what the metaverse is and why we all want it, I'd be quite interested. Unfortunately, it's a term that's got out there and is being bandied around. Probably the key difference is the metaverse includes a collaboration. And we actually offer that, but in metaverse, you're supposed to collaborate. It's supposed to be your avatar talking to somebody else's avatar in a virtual 3D world. That's kind of the meta Facebook, what they're talking about when they say metaverse. We go halfway there. We do provide collaboration tools, but there's no avatars. You're just communicating, looking at the 3D model and communicating with each other. So I have been at Christmas parties where people have asked me what I do, and after talking for 10 minutes, I said, we're industrial metaverse. And I went, oh, okay, great. That makes sense. So it's kind of a blurry line. I think digital twins are one piece of a real metaverse solution.
Perfect. Michael Wong is asking, can we discuss more about the facility/building management challenges of embracing IoT solutions, examples, sensor data, where stakeholders often talk about how their existing building systems meets the static automation needs, and not everyone may be interested in tighter controls for energy saving when there are potential subconscious threats towards tenant comfort?
Wow, that's pretty psychological. I think the one anecdote I can give, and again, this comes from my board member who has got extensive experience with facilities. The guys who actually run buildings, the guys who are there to check on the building and see what's going on and turn things on, turn things off. And they're not technologists generally. They come from they've had careers doing in the army or navy or something else, and then this is something they do later in their career potentially. So again, if you give them something complicated, they're going to ignore it and walk around with a clipboard and a pen. If you give them something easy, then I think we can make progress. In terms of the psychology of tenants being threatened by the building controlling their lives, yeah, that gets into privacy and security, and again, that's a big part of the reason we're thinking long and hard about the building control use case, because there is all sorts of, there's gotchas and potentially legal issues and security issues and a lot of stuff to think about there. Hopefully that answers the question. It was a lot of different parts to that one.
So I want to build on that. Another question by an anonymous attendee who is talking about more the comfort side of things. So when, really what happens when the ideal parameters, for energy efficiency and whatnot, differ from an individual's ideal settings. In other words, they want a little colder in the summer, a little warmer in the winter, or even within a household where you have one person who wants to crank the heat and the other person wants to lower it. How do you deal with those differentials?
Can I answer that one?
Yeah,
because
please.
Yeah, thanks, John. Look, we get this a lot. A lot of the work that we do is about the socioeconomic impact of the interventions that we make. So we get asked a lot about, we don't want the computer telling us that we've got to have it at this or we've got to do it at that. Now, I think in any of these systems, there needs to be the ability for a certain amount of override or a certain amount of intervention. If you're talking about control systems, that's, the control systems of the future will learn how we do things and how we like things. Buildings will be built more intelligently, and let's not overlook the fact that if in a new build you get the fabric of the building right in the first place, not only is it easier to achieve zero carbon in terms of whole life rather than just operational energy, it's also easier to achieve the comfort levels that most people like. Then you don't have to intervene so much anyway. And also those buildings are much lower energy usage in the first place. So on the old basis that if it can't be measured, it can't be managed, you need to know where your things are and what they're doing in order to make sure you're optimizing them at best. But I do believe that people are always going to want to be able to press a button at some point, because that's what we do. So I would like to see most systems learning, artificial intelligence taking over and doing things for us, but I don't believe it will ever be fully artificially intelligent, because people just like to press stuff. And you're quite right, Mike. To be fair, my wife's always cold in the winter and I'm always taking my jumper off because it's hot in the house. So there's always
sweater for our American viewers.
Yeah, exactly. It's always going to be that. And I don't think you can look, buildings don't use energy, people do, okay? We're the problem. If we change the way we do things, then maybe, and with intelligent systems, maybe we can drop our energy demand and start to decarbonize our future. We all have to play a part in this. This isn't just me, and it isn't just John, and it isn't just you. It's everybody. We all need to be thinking about it. But I'll get off the soapbox now, guys.
Yeah, I think there's a couple of corner cases you do want to pick up on. The guy who turns the heat up and sleeps with the window open.
Yeah, sure.
Being able to know that's happening is useful information, because obviously that's something that potentially there is a case for intervening, or like they're growing 50 marijuana plants in their dorm room. That's the stuff. Then that stuff happens.
Yes.
So being able to pick up on those extremes cases where it's like, hey, that's just not cool. But I everything I'm experiencing about people under the age of 35 or some number, the millennial generation, I guess. And as you get younger, they get more intense. It's like, hey guys, we don't want to cook the planet. We don't want to live, we don't want the sea to rise 20 feet. And mostly pissed off with the boomer generation, which I guess I'm part of. That we've wasted the Earth's resources, which is completely valid. But I think as human society progresses, it's become less and less of an issue, because people are getting so concerned and getting very, very, worked up and passionate about the whole subject, and keen to. It'd be like drunk driving. Going, the 60s it was fine. By the 80s it was a really bad idea. You got pilloried for doing it. So I think that societal shift is happening.
Yeah, I agree with you, John. That a lot of the younger members of our team are far more passionate, should I say, than I may have been. But I get infected by their enthusiasm, and I carry Now, I just have the honor of leading them. You know, we have a great team of people who are very well educated and very well qualified, and they're absolutely passionate about making changes. And I think if that spreads out across the whole of society, then pretty soon this will be like a snowball rolling down a hill. There'll be no stopping it, you know. But it just takes a few of us to push the snowball, which is, I think, where we are.
Well, on that point, you mentioned everybody has a role to play. Dion is asking, do you believe that the right recipe for all of this to be achieved is through close interaction of society, academia, and industry?
Yeah,
I mean, universities are leading the charge on this. We work with them a lot, leaders as well.
Yeah. So we were originally part of a 10 university research program into intelligent energy systems and various other facets of buildings in the UK. We were set up under what was called the Transforming Construction Challenge, with the idea of doing just that. And I do believe we've had some success, you know, but we're still going, you know, we're not finished yet. We've got a long way to go and a short time to get there. And all of the digital tools that we're talking about here are just valuable pieces of our armory. You know, we use them all day to try and make buildings and decarbonize better.
So Derek is asking, how much baseline data do you actually need to optimize a building using a digital twin? And does that differ from a new building to existing buildings?
Good question. I mean, obviously, the more data you collect, the better it gets. We see buildings who, you know, they measure the data, just the energy going into the building. We see buildings where they measure the energy on each floor. We see buildings where they measure the energy at each socket. The more granular you get, the better your results are going to be. And the longer you collect that data, the better your results are going to be. But I'd say, if you know, probably to make a difference, because just measuring the energy going into a building, it's real hard to figure out where that energy is going. But if you're measuring the energy at each floor, at least, and you've collected that data for a month or so, you've probably got enough information to start making some decisions.
Yeah, I'd echo that as well, because we've doing projects with people like the Welsh NHS and National Health Service, for those that don't have it. Sorry, couldn't really.
Point.
We monitor at circuit level, because we need to know what individual circuits are doing. For example, we were looking at one building where we've realized that they've got these huge chiller fridges running 24/7 with nothing in them. Why are you running them? You know, you want to save hundreds of thousands of pounds, turn them off, switch them on when you need them, or when you're going to put something in them. But that happens all the time. We waste so much energy, and the reason we waste a lot of it is because we don't actually realize it's doing it. You know, the old adage of last person out, turn out the lights, but mostly the lights are left on when somebody goes home.
Yeah, I mean, go downtown in any American city, it's lit up like a Christmas tree all night.
Yeah.
Which is always frustrating for me when I'm walking around and going, why the hell's that office building got every light in every office on for no reason?
Yeah. Same in London, but yeah.
So we have another question. It's a bit of a long one from Kangana. What's your view on interoperability for the success of such a twin model based on IoT sensors? Do you think we have reached that level where we can deploy these solutions in different types of buildings? And another question, can powering the buildings with numerous sensors for the twin put a strain on energy efficiency itself? Okay. How can we take care of it?
All right, I'll handle that one. So yeah, the sensor interoperability has come a long way. You know, I don't know if I'll go into the technical details, but almost every sensor will communicate over a standard Ethernet network at this point. There's different protocols. Then you have standard software that runs in the gateway in the building that will handle all of those protocols, taking the information from the sensors, convert it into a standardized format, transmit it to the cloud in an encrypted message. Those messages do come into us in different formats. They're usually all in JSON, but how the JSON is actually laid out is different from, you know, sensor manufacturer to sensor manufacturer. So we then put a translation service at the front of our service that takes in any JSON and reorders it to the format that we need. So we've put a lot into that very issue, which is we had this silo of each sensor manufacturer doing it differently, and therefore you could only work with, you know, their back end. You had 4 different systems to log into. So we've kind of solved that problem. It's you know, it's just a lot of work to get that translation service for each sensor manufacturers format, but we've done a lot of that already. And then in terms of powering sensors, they don't really use any power. The current sensors, the ones we talk about for the most part, are passive. They clamp around a current, and they use less than a remote control's worth of energy to actually actually make the thing work. So I don't think the sensors themselves are the problem. I think you're going to save way more power by having them than they consume by being there.
So just to give you both a sense, we have about 14 questions still to answer.
Okay, good.
In about 10 minutes to get through them. So we're going to try and get through as many of these as we can. Richard is asking, how do digital twins play into the idea of recyclable/reusable buildings that can be moved and are modified in a modular way when they have completed their initial purpose?
Okay, that's a good question, actually. It's, because we are currently looking at quite a few modular movable building types, specifically in places where there's high levels of homelessness. So we can effectively deploy modular movable buildings onto, say, car park sites, so they can be used to house people temporarily. And I'm sure that those things could be used for refugee crises or other stuff, quite quickly. These units are quick to put up, easy to power because you can do most of it by solar because they're very low wattage in terms of running, and can be deployed fast. But also, if you're monitoring them and modeling them at the same time, you have a standard archetype for these buildings. You can easily take an archetype of a building that you've got a digital twin of and put it on any site at any orientation and see how it's going to work. So, I mean, you're effectively lifting the site up and moving it before you've actually lifted it up and moved it. So yeah, I don't see the reason why that couldn't improve the situation for modular movable buildings. Certainly would help councils here, housing associations, local authorities create emergency accommodation and things like that, which is, I guess, what we were thinking. So, yeah. Yeah,
just to add to what Lee said, I mean, I think in the whole building world, there's a change going on from, one manufacturer having the sensors and the hardware and the control system and the software, and your fairly proprietary systems. They're somewhat open, but generally, once you use that system, almost everything is inside that system. What I'm seeing now is, we do the visualization piece. Somebody else gathers the data. The sensors are coming from all sorts of different manufacturers. Behind us is analytics and artificial intelligence, and any application you can think of that could consume this data, like this one we're talking about. So I see this whole building management. There's going to be multiple manufacturers, multiple vendors providing the overall solution, and you'll be able to pick and choose. Kind of going from like the mainframe world to the PC world. Mainframes used to be, you bought your mainframe from IBM, you ran all the software that IBM provided, and then the PC came along, and now you could choose your hardware, you could choose your software. Kind of seeing that same change happen in this industry. And if there's somebody out there doing recycling and software to help with that particular use case, we can plug into it. I'm sure
combine a couple questions here. One from Hugo's asking, how would a digital twin help private and public sectors to decarbonize home buildings and government buildings? And somewhat related to that, Steve is asking, is it possible to do that kind of visualization at a city level using digital twins?
You take the first one, Lee.
Yeah, okay. So no, this is what we do all day long, is helping governments and developers decarbonize buildings. And we always use digital twins and location-specific dynamic simulation modeling because it's a lot more accurate and a lot more helpful when you're trying to work out on your particular site what problems you may run into. And that applies whether it's new build or upgrade retrofit. It doesn't matter to us. The methodology is the same, the blueprint's the same. It's just a different set of variables, and it can all be done. Decarbonization. The problem is, when you talk about net zero and you talk about carbon, are you talking about operational energy in use? Are you talking about embodied carbon? Are you talking about whole life carbon? Most people don't understand the difference between three, let alone how to tackle it. So part of our remit and the reason we were set up was to help educate people into decarbonization. You can't just give them a system, expect them to use it. You need to make it intelligent enough to help them to use it. And we spend a lot of time with John's team trying to make models more interactive, better. You know, there's a lot of things on the list that we still want to do, but we've got a situation now where we could actually go into a new build development for, say, a local council here in the UK that we're building some accommodation, and we could have zero carbon homes, both embodied whole life and operational energy in use without any real problem at all. My problem is we're not doing enough of them fast enough, and it takes a massive sea change in our industry to make it happen. But I'll do as many as I can, as fast as I can, for as many people as I can. So,
and then the question on the city level, yeah, there's no real limit to detail levels you can display. There are people doing kind of city level, but it's much more simulated energy usage rather than actual measured energy usage. But from our point of view, yeah, we're already doing university campus level stuff where we have your 80 buildings and you can navigate around. We can create those models from photogrammetry scans, fly a drone around the campus, taking all that data and use that to create the high level model, and then drop down into the details of each building. I mean, the only limit is really memory in whatever computer you're using to look at this stuff on. But a building would be, a building in detail with all the energy information. It's probably 100 megabytes of data, 130 megabytes of data. It's one of the advantages of the gaming technology. They've crushed the amount of data you need because they want to run on mobile phones. So compared to using a full-blown CAD software from someone like Autodesk, using a gaming engine, you're dealing with much less actual raw data size. So you can do very large areas and probably run it on an iPad.
Mazad is asking, what are the key challenges that you are facing for making the building smart and using digital twins?
The inertia of the industry, I think, is probably building operators hate anything that adds cost. They work off. Well, there's a couple of things. Cost is definitely one. Inertia is, and cost leads to inertia. If it's going to cost them money and they don't have to do it, they won't do it, or they'll try not to do it. Property management companies operate off relatively thin margins. I think that's why universities have been so keen, because they've got a lot more money and they're keen to display their green credentials. But the guys who run large apartment complexes in New York City, it's all about dollars. The other problem you do run into in some buildings or commercial buildings is, the people who built the building are not the people who run the building and are not the people who occupy the building. So you've now got who wants to foot the bill to install, the energy sensors and turn the building smart. Well, the guys who are leasing it for 2 years don't want to do it. The guys who are running the building on a 10-year lease don't want to do it. So you sometimes run into that, where multi-owner, multi-user tenancy gets hard to find the person who's going to actually foot the bill. So how's that going to get solved? Might be things like government regulations, where governments or regional state governments or federal governments just say, hey, we're going to measure your building, and if it's not net zero, you're going to get a fine every month until it is. But I think dollars and cents. Once there's dollars and cents in it, then you're going to see a big change.
I think people will end up being penalised. Sorry, Mike.
Go on.
I just think people will end up being, it'll start at the top and work its way down, but people will end up being penalised for not doing it. And let's face it, people only generally do things two ways, to pick up on John's point. They're either incentivized to do it or they're legislated to do it. One or the other will end up happening at some point, I'm sure. Just what sectors it hits first and how it works, I have no idea, but I suspect it will come eventually. And different governments will take a different political view on it, but yeah, it's going to happen one way or the other. Why wait? Why not just do it now?
Yeah, exactly. So Patrick is asking, he can see how security challenges are easier when the IoT is monitoring only, but when trading and incentives are involved, could there still be risks with users spoofing data?
Yeah, I mean, I think that's where it's outside of my area of expertise, but I think that's where I joked earlier about crypto energy, but I think blockchains and things like that start to come in, because you're going to have to prove that this data is real data and it wasn't spoofed by somebody to get themselves credits. Because I mean, yeah, what a great hack. I can hack into the system, pretend I'm generating a ton of energy, and I get my utility bill turns positive. You know,
Yeah.
I can
It's
see
like
people
putting a
doing that.
magnet on the meter in the good old days, Johnny.
Yes.
I think, look, you know, I mean, let's be honest about it. I don't believe there's any really completely foolproof systems out there. I'm sure people in the Department of Defense would disagree with me, but I mean, you know, if you've got 12-year-old kids being able to hack something, it's always a very real possibility that these things could be interfered with. To what extent, again, I'm not an expert. I don't know. I can't really answer that question with any surety other than to say that I suspect that anything you do online could be open to tampering with. But maybe they've got bigger fish to fry. I don't know.
Yeah, you can do a lot around security, and what you don't want to do is tell people what you're doing, because that puts a target on your back for every hacker in the world. So that's, you know, you've got to be quite confidential about it. There are very secure ways of exchanging data these days, and I do think blockchain has its uses. Obviously, cryptocurrency was the first use case, but proving data is real is really what blockchain is designed for medical records and where agricultural foodstuffs come from and artwork, whatever you want to call it. When you need to prove that something is what it says it is, that's where blockchain really starts to shine. So I think that's what will happen. We'll end up using those technologies. And
I think if you look at it from sort of where I come from the sort of controlled microgrid point of view, it's moving energy around a closed environment, a bit like CCTV. You know, it's only interacting with the grid at a point, and that point could be where you have the complete control. So I think there are layers of security needed, and I think that those layers will come depending on your use case.
Mm-hmm. I'm gonna have to cut us off here. Our time is up, but I do want to thank both of you. This has been a great discussion. I am sorry to all of our attendees whose questions we did not get to. I'm really impressed with the not only the quality of the questions, but the quantity. For all of you, please remember to join the next session immediately following this. It's securing the evolving needs of the connected building. I thank you all for joining us today for this exciting discussion and this exploration of digital twins and the incredible opportunity that they create for impact and decarbonization. And once again, thank you to our friends at IIoT World for making this all possible and bringing us all together. Lee, John, thank you for your time, your insights, and for all that you are doing.